Hi, I am Sebastian Gondron from the Technical University of Denmark, and I'm going to present a paper with Sebastian Mödersheim, Vertical Composition and Solid Payload Abstraction for Stateful Protocols. Let us illustrate what we mean by vertical composition. So we consider a login application, for instance, one that looks like the Danish name ID, where a server sends to a client a nonce or a number, and the client can look up on a pre-shared card the corresponding secret. And then the client sends back the secret to the server. And this kind of protocol, of application protocol, is usually run over a secure channel, such as TLS in browser session, for instance. Here we have a very simple channel protocol. Of course, they can be more complicated, where they specify how the keys are exchanged. But here we just consider that the channel transmits the payload from an agent A to an agent B with a secure, with a pre-shared key. And here we see that in our channel protocol, the payload looks like a fresh nonce, for instance. And this is actually how many works that verify channel protocols models payload by fresh nonces. But when we consider the composition of these two protocols, it's actually fairly more complex messages that are transmitted over the channel, namely the messages from the application. So when the server wants to send a message to the client, it will in a way give its message, the change NS, to the channel that will transmit it encrypted to the client. And then the client can also answer back by also giving his message to the channel that can transmit it encrypted. And the question we're trying to answer is such a composition secure, given that the components are secure in isolation? In other words, can the channel be replaced by a different one? Or can the application be replaced by a different one, without having to verify the whole vertical composition again? And in general, these kind of problems, the composition of protocols with shared states, is hard to get right. So let us try to give an answer to that question. We consider an application, a channel, we consider that they're secure in isolation, we consider some conditions, they're syntactic and easy to check, we give them in details in the paper, and can we say that the vertical composition is secure? So the first idea was to recast this vertical composition as a power composition using the results of Hess, Mödersheim, and Brucker. So we consider those two protocols, and we say now that they are running in parallel. And we say that they share sets as an interface that we call inbox and outbox. So how does it work? When the server wants to send a message to the client, the server inserts its message into an outbox set, and the client will later retrieve a message from his inbox. And when the client wants to answer, the client can insert also its message into a similar outbox set, and the server will later be able to retrieve the message. And what the channel does is to actually take messages from an inbox, from an outbox, and insert it to a corresponding inbox. And the transmission is done, well, here by encrypting it with a shared key, but it can also be a different channel. So we first had to extend a number of theorems from these power composition results, but what the Hess, Mödersheim, and Brucker did is to simplify this power composition into two smaller problems, namely the components in isolation with respect to the idealization of the other protocol. So what the idealization of the protocol is basically the specification of what the protocol can do with the shared sets. So let us look at the two components in isolation now. So let us start with the application with respect to the channel idealization. So verifying the application means that the application has no attack as long as the channel behaves as it is specified in idealization, meaning that it does not do anything unexpected with the inbox and outbox sets and does not leak secret messages. And if we take a look back at our example, this means that the way messages are taken from the outbox and inserted in the inbox, in other words, the way the messages are transmitted, is not really important for the application as long as what is guaranteed in terms of security properties in the idealization of the channel is respected. And we can now verify the application independent of the channel. But we can also now verify the application with respect to any idealization of the channel that is the same. Meaning that if we consider a different vertical composition with the same application, but a different channel, but this channel has the same idealization than the previous one, then we have already verified the component of the application. But this is not enough, because the other component, namely the channel itself, is actually harder to verify. And intuitively, it is because the channel, or the concrete execution of the channel, has some concrete messages from the application. The application has inserted messages in the outbox that the channel also manipulates, and the channel will transmit messages that contains as subterms messages from the application. And this means we cannot verify the channel independent of the application. And this should be simpler, and this should be more general, because we don't want to consider to verify the channel every time we consider a new application. So what we did is we proved a sound abstraction of the channel. In particular, we proved a sound abstraction of the payload variable. And we replaced it by an abstract constant that can be known to the intruder or not, or can be fresh or reused. And the channel has now access to an infinite pool of abstract constants. And this is very close to the idea of modeling the payload by abstract nouns, but we actually proved that this is a sound abstraction. And so, to recap, what we did is we recast the vertical composition of an application and a channel into a parallel composition. And we needed to do that to extend the number of results from Hess, Mödersheim, and Broca. And then we gave a sound abstraction of the channel. So now the two components, the abstraction of the channel and the application with respect to the idealization of the channel, this is two components that can be verified independently by most existing tools. Also, tools that cannot use sets, because sets can be encoded in a different way. Thank you for your attention.